Good morning everyone. My name is Deepika from Bsc Chemistry Honors second year. I am here with the topic of aldehyde and ketones. Today I will discuss about aldehyde and ketone. I will tell about main points about aldehyde and ketone. So, what is aldehyde? We will see the definition of aldehyde. So, what is aldehyde? Aldehyde is that species in which at least one hydrogen atom is attached to C double bond O group, that is C double bond O group, that is CHO group, is present in their structure is called aldehyde. For example, CH3 C double bond OH, and the name of this compound is ethanol. Aldehyde ketone. Aldehyde primary functional group name is ALL, and its sign is CHO. Now next we will see the definition of ketones. In ketones, the species in which no hydrogen atom is present and its group is C double bond O. Group, that is alkyl or aryl group, is attached to C double bond O group is in their structure. For example, now we will see one example. CH3 C double bond O CH3. The name of this compound is propane 2-on, or we can also say acetone simply. After that we will see types of aldehyde and ketones. Now types of aldehydes and ketones are, they have many types. For example, we will see the types. We will write about the types. Aliphatic aldehyde and ketone. Second is symmetrical aldehyde and ketone. Next is aromatic, mixed, first one is aliphatic. Aliphatic, in which aliphatic aldehyde and ketone we will see CHO and CO group is present on alkyl group are called aliphatic aldehyde or aliphatic ketone. For example, now we will see the example of this. CH3 C double bond OH, this is simply ethanol, and second one is CH3 C double bond OCH3, this is propane 2-on or simply acetone. The aldehyde or ketone, which are formed by the replacement of one or more hydrogen atom from the aliphatic hydrocarbon from like CHO CO group, are called aliphatic aldehyde or ketone. Next is symmetrical aldehyde or ketone, in which same group are present. For example, same group are attached to the carbon, to the aldehyde or to the ketone. Here we can see to the ketone two benzyl group are attached, which both are same. And second one example is, we will see CH3 C double bond O CH3. In this also two groups which are attached, they both are same. Next one is our aromatic. Aromatic aldehyde or ketones, the species in which CHO COR group is attached on benzene ring. For example, we will see, this is the example of aromatic CHO, and next one is CO COCH3. In this we can see aldehyde is attached to benzene ring, and in this example we can see ketone is attached to benzene ring. The name of this benzene aldehyde. Next is our mixed. In mixed or in mixed aldehyde or ketone, we will see that different groups are attached to aldehyde or ketone. For example, CH3, C double bond OH. In this example, we can see that two ketone, two different groups are attached, here H and here CH3. And next one example, we will see the example CH3, C, CH2 and CH3. Here we simply can say two ketone, two different groups are attached, and the name of this compound is butane 2 on. Okay, next we will see. Now we will see the next physical properties. Physical properties of aldehyde and ketones. Now I am writing the short form. Now we will see the aldehyde and ketones. Boiling point and melting point. Now we will see the boiling point and melting point. The aldehyde ketones or have polar C double bond O group, and thus there is a strong dipole force between the aldehyde and ketones molecules, and thus more heat is required to break that bond. To break that strong dipole force of attraction present in between aldehyde and ketones molecules. Therefore, we can say that the boiling point is high and melting point also high. Next, we will see about solubility. Solubility of both. So the aldehyde and ketone have polar C double bond O group, can form H bond water molecules. So the members of the aldehyde and ketones are soluble in water. They are soluble in water, but for example, the hydrocarbon part increases in the higher aldehyde and ketone, so the H bonding do not occur. In this, we will say that are not soluble in water. In lower part of aldehyde and ketone, they are soluble in water, but in upper part they are not soluble in water. Okay. Next, I will say about that aldehyde and ketones are chemically reactive or not. We will write aldehydes and ketones are chemically reactive or not. We will see this. So here we will see that they are chemically reactive. They both are chemically reactive because of two main factors. Two main factors. The two main factors are that C double bond O contains the reactive pi bond. First factor is that our, and the next factor is that due to high electronegativity difference between carbon and oxygen atom, they occur separation of charge, and thus the C double bond O is polar in nature, and I will repeat my line. Due to high electronegativity difference between carbon and oxygen atom, they are highly charged and these occur separation of charge, and from this they are polar compound. Okay, and polar compounds are reactive in nature. Are reactive in nature. Okay. Next we will see aldehyde and ketone shows nucleophilic addition reaction or not. Nucleophilic addition reaction. They show nucleophilic addition or raw. We will see that due to high electronegative difference we have explained in upper part. Carbon and oxygen atom, there occurs separation of charge and there is unequal high pi electron density between the carbon and oxygen atom. So less electronegative central atom acquires slight positive charge and more electronegative neighboring atom require slight negative charge. Less electronegative require slightly positive charge and more electronegativity requires slightly negative charge. Okay, and then nucleophilic will attack on central atom, so they show nucleophilic addition reaction. They show. Okay, now I will tell about the next topic, that is Reimer-Tiemann reaction. Okay, I will write the reaction name, Reimer-Tiemann reaction. In this reaction we will see salicylaldehyde. We will see the phenol which is changing to salicylaldehyde and salicylic acid. So we will see here, we will write here phenol. We have written simply phenol. Now it have two reaction and we will see both reaction. First reaction we will use that Reimer-Tiemann, wait, okay, Reimer-Tiemann reaction. Here we will add CCl4, chloroform, KOH at 333 Kelvin temperature and Reimer-Tiemann reaction. Okay, now we will see the next our product, which is salicylic acid. And here we will see that when we will add CHCl3 and KOH at 333 Kelvin temperature, we will see the product. Here we will see the product, salicylaldehyde. Now next we will see Gattermann synthesis. Okay, synthesis. In this we will see that phenol is changing to salicylaldehyde. So we will see how it changes to aldehyde. Sorry for my that. Here phenol is changing to salicylaldehyde at the presence of HCN, HCl, AlCl3 and hydrolysis, and we will see Gattermann synthesis. Now we will see the product. Here we will see OH and CHO, that is salicylaldehyde. And next we will see the electrophilic substitution reaction of Hoban-Hosk reaction. Okay, in this we will see OH, resorcinol, resorcinol, converting to in the presence of CH3CN, HCl, AlCl3 and hydrolysis, which is here, and we will here Haber-Bosch reaction. Okay, it is completed. Now next we will see the topic of conversions. Now we will see conversions. Some conversions we will see. Okay, for example, our first conversion is methanol into methanol. Methanol into methanol. So here we will write methanol. It is our methanol, and firstly we will write methanol. After that I will tell about the catalyst which is used to change it. This is our methanol, and the catalyst is LiAlH4 in the presence of heat. It is very easy. Second conversion we will see is methanol into ethanol. Methanol into ethanol. Here we will write first methanol. Here we will add CH3 MgBr. CH3 negative, MgBr negative. It will attack on this. It will goes to this. Now the product is CH3 CH ONGBr. It is positive part, it is negative part, and now we will add water to it and CH3 CH2OH. So our product is that ethanol. In two steps we will convert this. After this we convert it into ethanol. Okay, now it is very easy, and next is so easy, so I will tell about that. Methanol into methane. We will write here methanol into methane. So yeah, we can write this way or this CH4, or simply okay, this is our methanol, this is methane, and the conversion that is used Hi, red phosphorus, and we heat. Okay, now here my topic is completed. I hope you like the what I taught you. Okay, thank you, have a nice day.